Assalamu alaikum dear students. In previous lecture we discussed the algebra of two functions. Today we are using the same concept in order to discuss this graph of the function f of x equals to 1 upon x. Now here this function f of x equals to 1 upon x has two parts, one numerator part and the second one denominator part. Numerator is 1 means constant polynomial, so its domain is R. And denominator portion, which is simply x, means identity function, it is again a polynomial, so this means that its domain is R. Now what about the domain of this whole function there, this, or what about the domain of this rational function, because 1 upon x it is rational. Now the domain of this rational function is those points we have to remove from this domain of the individual domains of these functions, where denominator is 0. Here denominator is x, which is 0 only when x is 0. X is 0, and the domain of this function numerator part and the denominator part is R. This means that we have to remove R in this 0 from that very set. That is domain of this function, that is 1 upon x, became simply R minus 0. That is we have to remove this 0 from this set R. Now how to draw the graph? For the graph we need two axes, one the x-axis and the second one is y-axis. In x-axis means in the domain axis we have to remove the point 0. Now here this, when we draw here two axes, this is x and y-axis, these axes intersect each other at this point. Here this small square means that we are removing, that is 0 is not in the domain. In domain we have all non-zero points, like 1 at 1 value is f of 1, which is 1. At x equals to 2 value is f of 2, which is 1 upon 2. That is when we increase x, when x increases 1 2 3 4, the value of the function decreases, that is it becomes 1 upon 2, 1 upon 3, 1 upon 4, and so on and so forth. So this means that when x increases, when x goes here, the value decreases means it comes towards 0. That is when we draw this, it is just like this, it increases, here it decreases. Now at endpoint, one endpoint is 0, but not exactly 0, but the point which is very close to 0. At 0, if we consider the value of the function at this, it is 0. It is f of 0 equals to 1 upon 0, which is infinity. So when x approaches to 0, means when we move towards 0, the value of the function becomes larger and larger, that is x tends to infinity. Similarly at infinity, because endpoint of this is 0, it is infinity. Now at infinity, when we substitute the value, it is simply 1 upon 0, 1 upon infinity, that is 0. So this means that at infinity it is 0, at 0 it is infinity. So the graph just looks, when we draw such graph, it just becomes like this. This is the inversely proportional graph, means one increases, the value decreases, or when the value decreases, the corresponding value increases. Similarly from right hand, this negative side, when we consider the negative portion of the domain, the graph becomes like this. So for, if we have the positive function, because here a function is positive in the first portion, the function is positive, which implies that in this portion, this is the positive proportional graph, inverse proportional graph. One increases, another decreases. Now here in negative side, this portion, this is negative inversely proportional graph, that is f of x is 1 by x, or f of x is minus 1 by x. This is called a negative inverse proportional graph, and it's like this. So this is the required graph. Now the question is, we have to find the domain of this function, this rational function, because here we have two polynomials, x square 2x plus 1, and x square minus 8x plus 12. Both are the polynomials, and it is the given function becomes the rational function. These individual polynomials are defined over entire set, or hence the domain of this f of x is simply obtained by firstly finding the zeros of x square minus 8x plus 12. That is simply by using the quadratic rule, or another rule. You can find the zeros of x square minus 8x plus 12, or x equals to 6, x equals to 2. So this means that the Rokkayo domain becomes, or the Rokkayo domain of this f of x is r minus 6 and 2. Now we have two relations, f of x which is given by x square for all the points between 0 and 3, and it is defined as 3x for all the points between 3 and 10 including endpoints. And the second one is g of x, which is x square, which is 0 less or equals to x less or equals to 2, and 3x, which is 2 less or equals to x less or equals to 10. We have to check which represents this function and which is not. Now here we will, here this 0, 3 and 10 in f of x, these are the critical points, because critical means where the function changes the behavior or changes its behavior. Here at 0 value is simply 0. At 3 value is either x square or obtained by finding from x square or by 3x. So this means that at 3 it changes the behavior, but at 10 the value is same as value of this f of x is obtained by simply putting in 3x. So we will check simply the value of the function at the critical points where the function changes the behavior, that is 3 and 3. Now in the first case the value is x square. When we find the value from this, it is 3 square, that is 9. And in second case f of 3 is 3 into x, that is 3 into 3, which is simply 9. So in both cases 3 is mapped, or the 3 is related with only one point, or the unique point, that is 9. So in this case it is simply a function, because every element or the domain elements have unique image in the range in the codomain set. Now if we consider second one, we will check the behavior at 2. The value of this 2 under this g of x is firstly 2 square, that is 4. Second one is g of 2 is 3 into 2, that is 6. This means that this g maps 2 with the two different elements, that is 4 and 6, which implies that the uniqueness is altered. When uniqueness is altered in a relation, so the given relation is never function, it is simply a relation. Hence in this case f is function, but g is not the function. So this completes this question. Now we have another question. The function is defined by x and x square upon 1 plus x. This means that because function is ordered pair, the first entry is x in terms of x, and the second entry is of the form of x square upon 1 plus x square. That is f of x is simply x square upon 1 plus x square. We have to find the domain and the range. Clearly in the given statement x belongs to R means domain is simply set R. Now what about range? Now here x belongs to R, which implies that when x is real, its square is positive, always greater or equals to 0. That is x square is always greater or equals to 0. Also in the first case, when x square is greater or equals to 0, non-negative means when we add 1 to this, it becomes always greater or equals to x square. That is 1 plus x square is always greater than x square, or 1 is greater than x square upon 1 plus x square. By interchanging the position, it is simply x square upon 1 plus x square is less than 1. Here this x square upon 1 plus x square, it's the range element, it is f of x, that is f of x is less than 1. So this is the one endpoint. Now what about second? Here x square is positive, means non-negative. 1 plus x square, it is greater than 1, or simply it is greater or equals to 0. When it is greater or equals to 0, which implies that their ratio is simply greater than 0, that is x square upon 1 plus x square is greater than 0. which implies that this x square upon 1 plus x square is simply f of x, that is f of x is greater or equals to 0. So the lower limit of this f of x is 0 and the upper limit is 1, but we have to include, but this lower limit is included in the set. So this means that this f of x simply belongs to closed from this 0 to 1, hence the range is interval 0 to 1 but closed from left hand side. So in this way we completed, I think, this whole unit. Inshallah, from tomorrow onwards we will discuss the third unit of this course, that is trigonometric equations or simply trigonometry. So thank you.